In 10.2, we talk about triangles. So a conclusion that is proved to be true through deductive reasoning is called a theorem. The Greek mathematician Euclid, who lived more than 2,000 years ago, used deductive reasoning. In his 13-volume book, Elements, Euclid proved over 465 theorems about geometric figures. And so a triangle is a geometric figure that has three sides, all of which lie on a flat surface or plane. Because the beginning and ending point are the same, the triangle is called a closed geometric figure. Euclid used parallel lines to prove one of the most important properties of triangles. The sum of the measures of the three angles of any triangle is 180 degrees. So given a line and a point, not on the line, and only one line can be drawn through the given point parallel to the given line. The sum of the measures of three angles of any triangle is always going to be 180 degrees. So we want to find the measure of angle A for triangle ABC in the figure. So we just need to add the three angles together, and this should give us 180 degrees. So the measure of angle A plus the measure of angle B plus the measure of angle C will give us 180 degrees. Well, we don't know the measure of angle A, but the measure of angle B is 120 degrees, and the measure of angle C is 17 degrees. And so we get that we have the measure of angle A plus 137 degrees equals 180 degrees. And so the measure of angle A is 43 degrees. We want to find the measures of angles 1 through 5 in the figure below. So we have two separate triangles. We have this triangle in pink, and we've got this triangle in purple. So each one of these will have a measure of angles of 180 degrees. So let's start with the purple triangle. That means that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3, which is 43 degrees, equals 180 degrees. Well, we can figure out the measure of angle 1 because it's a right angle. So it has to be 90 degrees. So we have 90 degrees plus the measure of angle 2 plus 43 degrees equals 180. But this is really the measure of angle 2 plus 133 degrees equals 180. Or the measure of angle 2 is 47 degrees. And we know the measure of angle 1 is 90 degrees. Now let's go over to the pink triangle. So we have that the measure of angle 3 plus the measure of angle 4 equals plus 60 degrees equals 180. Well, we know that the measure of angle 3 is 47 degrees because it's a vertical angle with measure 2, with angle 2. So we have 47 degrees plus the measure of angle 4 plus 60 degrees equals 180. But that's the measure of angle 4 plus 107 degrees equals 180. Where the measure of angle 4 equals 73 degrees. And that's because the measure of angle 3 is 47 degrees because it's a vertical angle. The only angle we have left is angle 5, which is over here in the corner. And the measure of angle 5 is just going to be 180 minus the measure of angle 4 because this is a supplementary angle. And so we end up getting that the measure of angle 5 is 180 degrees minus 73, which is 107 degrees. Triangles can be described using characteristics of their angles or their sides. And so by angles, we have an acute triangle where all the angles are acute. We have a right triangle where one angle measures 90 degrees, and an obtuse triangle where one angle is obtuse. We also have by sides. So an isosceles triangle means that two sides have equal length, and the angles opposite these sides have the exact same measure. An equilateral triangle means that all sides have the same length and each angle will measure 60 degrees. And a scalene triangle, which means no two sides are equal in length. Similar triangles, figures that have the same shape but not the same size, are used in scale drawings. A scale drawing always pictures the exact shape of the object that the drawing represents. Architects, engineers, landscape gardeners, and interior decorators use scaling drawings in planning their work. Figures that have the same shape but not necessarily the same size are called similar figures. In the figure below, triangles ABC and DEF are similar. So one has the sides of 6, 8, and 4. The other one has 3, 4, and 2 respectively. You can also see which angles correspond with the other triangle's angles. So A and D measure the same number of degrees and are called corresponding angles. Angles C and F are corresponding angles, and so are B and E. Angles with the same number of tick marks are the corresponding angles. The sides opposite the corresponding angles are called corresponding sides. Thus, CB and FE are corresponding sides, AB and DE, and AC and DF. Corresponding angles measure the same number of degrees, but corresponding sides may or may not be the same length. In the figure above, each side in the smaller triangle is half the length of the corresponding side in the larger triangle. The triangles in the figure illustrate what it means to be similar triangles. Corresponding angles have the same measure, and the ratios of the lengths of the corresponding sides are equal. So in similar triangles, the lengths of the corresponding sides are proportional. So AC over DF is equal to CB over FE and AB over DE. So how can we quickly determine if two triangles are similar? If the measures of two angles of one triangle are equal to those of two angles of a second triangle, then the two triangles are similar. If the triangles are similar, then their corresponding sides are automatically proportional. So explain why the triangles in the figure are similar, then find the missing length x. So let's look below. We have this angle with this angle, and those are similar. We also have these vertical angles going on the inside. And that means that these are the same length, since they're vertical. So because two angles are the same, then the triangles are similar. Since we're looking for the length of x, and these are similar, we know that we can use corresponding sides. So 5 corresponds with 8, and this is equal to 7 over x. So this side and this side correspond, and x and 7 correspond. And so we can do cross multiplication here. So we get 5x equals 56. And so x equals 56 over 5, which is 11.2. A man who is 6 feet tall is standing 10 feet from the base of a lamppost. The man's shadow has a length of 4 feet. How tall is the lamppost? So in the geometry sections, it usually helps to draw a figure. So I'm going to draw our lamppost and the shadow that it casts. So we want to know how tall the lamppost is. So this would be x feet tall. We know that it casts. We have a man standing 10 feet from the pole. So let's just draw a vertical line to represent the man. We know he's 10 feet from the pole and that he's 6 foot tall. His shadow is 4 feet. Now a lamppost with the ground is going to give us a 90-degree angle, and so will the man. Now this angle in the big triangle is the same as the angle in this small triangle. And so because they're the same angle, they automatically have to be the same measure, which means we have two angles that are the same. We have two angles at 90 degrees, and we have the common angle, which will automatically be the same. So these two triangles are similar. And so we can compare their corresponding sides. We have x over 6, and that has to be equal. And this, the whole length is going to be 14 because it's 10 feet plus the 4 feet all over the 4 feet. So we have x over 6 equals 14 over 4. We can cross multiply. So we get 4x equals 84, or x equals 21 feet. So our lamppost is 21 feet tall. The ancient Greek philosopher and mathematician Pythagoras founded a school whose motto was "all is number." Pythagoras is best remembered for his work with the right triangle, which is a triangle with one angle measuring 90 degrees. The side opposite of the 90 degrees is called the hypotenuse, and the other sides are called legs. So the sum of the squares of the lengths of the legs of a right triangle equals the square of the length of the hypotenuse. And so what you guys know this usually as is a squared plus b squared equals c squared, where c is the hypotenuse and a and b are the shorter legs. And the hypotenuse will always be the longest side. So we want to find the length of the hypotenuse c in the triangle shown below. So because this is a right triangle, we can use a squared plus b squared equals c squared. It doesn't matter which one is a or b, so we end up with 9 squared plus 12 squared equals c squared, and that's 81 plus 144 equals c squared, or 225 equals c squared, and we want to have just c. So we take the square root of both sides, and we get that c is 15, or 15 feet. Did you know that the size of a television screen refers to the length of its diagonal? So if the length of the HD TV screen is 28 inches and its width is 15.7, what is the size of the screen to the nearest inch? So let's go ahead and draw a picture. We've got a TV, and the length of the diagonal is the size of the television. And so that's what we're trying to find out. So you can label this as C, because all these corners are right angles. We know that the length is 28 inches, and we know that the width is 15.7 inches. So this is a right triangle problem as well. So we're going to use the Pythagorean theorem again. We're trying to find C, or the size of the television. So we have 15.7 squared plus 28 squared equals c squared. Well, that's 246.49 plus 784, which gives me 1030.49 equals c squared. And let's just round to the nearest inch, which we get about 32 inches. So my television would be a 32-inch TV. And a wheelchair ramp with a length of 122 inches has a horizontal distance of 120 inches. What is the ramp's vertical distance? So let's draw a picture again. So we've got our ramp, which is a right triangle. We know its length, which is the actual ramp that you would roll up or roll down, is 122 inches. So in this case, we're actually given C. The horizontal distance, which would be the part that's on the concrete, is 120 inches. We want to know the ramp's vertical distance. And so you could label this as A or B. So it's still a Pythagorean theorem problem, but we'll be solving for A instead of C. So A squared plus B squared equals C squared. We don't know A, but B is 120 and C is 122. So we get A squared plus 14,400 equals 14,884. But that's just A squared equals 484, or A is 22 inches. Now, construction laws are very specific when it comes to access ramps for the disabled. Every vertical rise of 1 inch requires a horizontal run of 12 inches. Does this ramp satisfy the requirement? So if we have a vertical rise of 22 inches, which is what we found out in Part A, we have to have a horizontal run of 12 inches. So multiplying that by 12, we end up with 264 inches, which is way greater than the 120 inches of our ramp. So this does not satisfy the regulations.